like I told my
Hello, everyone. How are you? Okay, so we're going to cover the next unit. I did receive some email regarding the program from the last lab. I'm working on fixing some of the issue, and so once I have it, I will re-release it, or I will let you know either via announcement or letting you know verbally in class. So let's take a look at your notes. And this one, we're going to use the presentation that came with the text. So let me share screen real quick. We got some chat message. Okay. All right. Okay, so you can download it here. You can view it inside your page, and then we're going to go through the assignment. Okay. So in this week, we're going to talk a little bit about your C programming statements and how that will correlate with LC-3. We are going to do a couple exercises to really write out some of a snippet of the program in LC-3 based on the given condition in pseudocode or C++ or C. So to start, we're going to talk a little bit about conditional statement. And we have been working with this for maybe a few weeks now. This is allowing us to really branch to the decision based on the conditions that is set. So your body of your statement, for example, in an if statement, that will be executed if your condition is true. So in LC-3, we would implement branching. And in this case, a lot of times we would be able to check what's in the register. If that's true, then it's going to execute the next line of the code. Now in LC-3, you don't see so much of the switch statement. A lot of the time you're going to see conditional with if and if else. And then we have been working with loops where we would iterate, and normally we can increment or decrement. So a lot of times we see this with like a while loop or a for loop. A lot of the labs that we've been working on is using the for loop. And we can also implement do while, but a lot of the times, like I said before, we would just use branching. So when you do your flow chart for your project and also your pseudocode, make sure that you include all your branches. So in this case, what we see that we would have an if statement, and you would have the condition that's stated with the if. So if this is true, it's going to execute the action here. If it's false, it's not going to execute the action here. So if statement, with the if, the body would execute only if the condition is true. So you would see that in this type of flow chart. And so what we can do is we can evaluate this in LC3 by using branching with either negative, positive, or in some cases 0. So if we want to check to see if something is equal to a number, we can subtract that number and check for 0. If it is 0, then it is true and it's going to execute the next line. Now, in the case where if we want to see if something is greater than a number, so if I want to say if x is greater than 4, then what I can do is I can subtract 4 and check for positive as I'm looking for x is greater than 4. If it is positive, then it is true. If it is not, then it would execute the else, or in the case if I only have the if statement, it will not be able to execute that label section of my branch. So we have to understand how to work with if-else statement. And as you can see in the following slide, it gives you some examples. So when you look at something like this, at this stage in the class, you should be able to take this and put it in LC3. For example, if I want to say if x is less than or equal to 10, y is going to be x times x plus 5. So I already know that I have to load x, right? And then once I load x to a register, I want to subtract 10 from that register. And as I subtract 10, I want to check at that register to see if it is negative, right? If it is negative or 0, then I know that it is less than or equal to 10. So when you see the statement in C, you should be able to think about, oh, what are the steps that I need to take in LC3? So if that's true, if it's checking for negative and 0, if that's correct, then I'm going to load y to a register. And then what I can do is I can use a function to multiply, or I can take x and multiply it by itself. So it really depends on, since I already load x, I can take that register, right? And then use that register with the function for multiply. And then after that, I will add 5. And then after I return from the multiplication, I would take the return register and then add 5. Okay? So we should be able to break it down into the substep. So when you look at the C statement, what you're going to see is that when we have one line in C, like the if or the control statement, you're going to have like maybe 2 or 3 lines in LC3 or even more, right? So we kind of have to really break it down into the subtasks for each of these. And so when you look at these examples, think about how you would write it in LC3. In the following slide, it's giving you some more example. And in this case, we also see that your logical operator is being used. So in this example, it says that if h is greater or equal to 0 and h is less than or equal to 11, and we normally see this as a range, right? We're going to increment kids by 1. So in this case, what you're going to have to do is you have to be able to take this variable, right, and then tie it to a register, and then check at that register to see if it's greater or equal to 0. So I would be able to branch positive and 0, right? And then after that, I also need to check to see if it's less than or equal to 11. So I would need to subtract. I can copy it to another register and then be able to handle that, or use that same register to be able to subtract 11. So that way I can check for negative or 0. If those things are true, then I'm going to be able to increment. So I will be able to add 1 to the register that represent the variable kids. Okay. And so when we look at that, we would just need to break it down into the sub pieces, handle one branch, handle a second branch. And then if those branches are correct, so we would branch and then branch consecutively from that same register. And then we would be able to execute this. So if that's true, then we're going to increment it by 1 for the variable kids. Okay. All right. Now the OR is going to be similar. So we want to tie the condition, but with the OR statement, you know that when we're using OR, only one of the condition on either side has to be true. So if I have the month is 4 or the month is 6, so it doesn't have to both be true compared to the AND. So the logical AND operator requires that both sides needs to be true, where the OR, one or the other can be true, right? So in this case, it's 4, 6, 9, or 11. So we are going to have to check 4, 6, 9, or 11. So how I would approach this is I would need to represent the month in the register, right? I need to take that, I need to subtract 4 and branch for 0. So if it's subtract completely, then I know that it's equal to 4. Then I also need to subtract 6 from that register and branch again for 0. And so on, 9 and 11. So you need to be able to operate the subtraction one step at a time and check each of the branch for the OR. So I branch after I subtract 4. Then I reload the register again, or you can also copy, take that, and then make sure that I subtract 6. Branch again, and then subtract 9, branch again for 0, and then subtract 11, branch again for 0. And if that's true, right, then I load effective address for this string, and then I would do a put. So we would be able to also lay out some of the load instruction steps when we see the statement. Any question? Okay, so let's go through and answer some of the basic questions. So for question 1, it asks you to describe the use of conditional statement in C programming. And as you see on the slide, this is a way that we can make decision, and this is hence the name branch, right? About which code to execute based on the evaluated expression. So if the expression is true, right, then it's going to execute the body of the control statement. If the expression is false, if in the case where if we're using if else, it's going to execute the else body. But if we only have the if, it's just going to skip it all together. So conditional or control statement, conditional statement is really looking at the condition or the evaluated expression as it is true. Now, in some cases, you can set that condition to be false as well, right? Like we can say, if this is false, then we're going to do this. We want to output some kind of string. So it really depends on the evaluated expressions. We can use bool, we can use different type. We can also use comparison operator to really check the value, as you can see in the example. So what are some of the conditional expressions? And when you learn C++ or Java, Python, you often would see conditional statement. So we normally see if else. In Python cases, you're going to see if elif, right? In the case that you can nest the if else inside the if else. So Python allows you to do if elif else. In C++ or Java, you would see that if else can be nested within. So you can have if right? If, and then the subcategory, you can have if, else, and so on. So you can nest these statements within. Now in C++ and in Java, you would see that you would have switch case statement or case switch statement. For Python, Python doesn't have switch. And for my class, usually I go over this type of statements. In Python. We would write function to be able to execute the switch. It still need to branch, but we can integrate the conditional statement in the function for it to branch accordingly. Now we talk a little bit about loops. So the next part, we're going to take a look at some of the loops. So we want to use iterative statement to be able to execute your code multiple times. And that's what looping is, right? We can loop it for a certain number of times, and that can be a for loop or for range. We can also implement a while loop, and we can have it infinitely executing where we don't exit the loop, but that would take up a lot of resources. So we have to really look at how we can implement a way for it to exit. In some program where you keep wanting to prompt the user, right? You should implement a way to really ask the user whether they want to continue or not, right? So let's say that you want to prompt them for the age, and it's going to keep prompting, but on there you want to say, press, a space bar to be able to exit the program. So we have to be able to get out of that loop at some point. So you would implement a condition with that while, so that way, in the case that if a certain key is pressed, it needs to exit. So iteration is about completing a certain task many times, and it would end based on the evaluated expressions. Okay, as long as it's true, it's going to keep going. When it's false, it's going to exit the loop, right? And in the case of the loop, we need to implement counter in the case that we want to control it for so many loops. So if I wanted to control it for 10 times, I can, in LC-3, you would initialize the counter at hex A, and then you would be able to decrease. So you would subtract 1 as it loops. And then we want to check for the branch. So we would branch when it gets to 0 or negative, right? It's going to go to skip or, the next part, another label where that will be the next part of our program. Any question? Okay, so we did loop over the last few weeks. We are going to do loop again for the number generator on Thursday. So you can take a look at the code and review it for your project. And so in iteration, the type of loops that we will work with, and your book uses C. So we're going to use C examples. So we have while, do while, and for loop for C. That's the same for C++ and Java. Now, for Python, for those of you who are familiar with Python, Python doesn't have do while. It only has a while and a for. So you can implement for range for, you can implement while loop, right? There's, the need for do while is not great in Python because we can implement other ways to really solve the problem besides using do while. So yeah, you have while, do while, and for C or C++. And so before we get to number 5, let's take a look at some example. So we talked about the nested if and if else. Let's see. So for the while loop, we know that anytime that for the test condition, if that's true, it's going to always execute the body. So in the case that you have the infinite loop, what it is just the test condition is always true. in order to exit out of an infinitely executing program, we have to build in when it would be false, right? So when certain condition is false, then it's going to exit. Or what we can do is we can have a while, and then we can implement the if. And you can do other things. You can do a do while if you're doing C++. Now, you know that one of the things, I think a lot of the students get confused when they first learn programming about loops and between the do while, the while, and conditional statement. Keep in mind that the while, your test is evaluated before executing the loop body. So it's evaluating what's in the criteria here before it executes this. And it needs to check for it's true in order to execute here, right? We see the test. If that's true, then execute the loop. So the example is this, and see if you can do it in LC3 in your head. So we have x is equal to 0, while x is less than 10. We want to print x, the value of x, assuming that this is typed as integers, right? So you would say int x initialized at 0 if you're doing C++, while x is less than 10, right? Then this is the body. And then we would take x is x plus 1. So we can do itself plus 1. This is an easy one. So on the right hand side, they kind of give you a little snippet for LC3. And we don't have to do exactly like this, right? So you see that they're clearing register 0. So that's initializing the register 0. And for the store here, we are going to take register 5 and 0, and we're going to store it to register 0. I feel like, do you absolutely need to do this? No, unless you want to use register 5 in order to kind of use it as a pointer to point to register 0 as that variable, you can. You can simply clear the register and then be able to load it, store and load. So you can do a store here. So you write register 0 as 0 for x, basically. And then you enter the loop. The reason why you need to store here, and you don't have to do str, is that when you enter the loop, your register value will change. So you need to store it right before your loop starts. Then you're gonna, after you store it, when you enter the loop, you're gonna load it. So here is where we're gonna start with the test condition. Remember that for LC3, you always gonna start from the inside out, right? So just like math, you start from the inside the parentheses and you work outward. So you're gonna start with the test condition, and then you are gonna work outward. So here is where we're gonna load x again, assuming that x is in register 5 or register 5 point to the x label. Then we're going to subtract 10. And so right now I'm evaluating the test condition. So add -10. And we want to see if it's less than 10. So we're going to branch to 0 and positive. We're going to go to done, which is the next part. If it's less than 10, then it's true. Then you are going to do the body here. We are going to load x. And then you have to ASCII convert it. So the ... here, you are going to take register 0, and then you're going to do either the decimal subtraction or the hex subtraction. We talked about that in the prior lab. And you want to keep it on register 0 so that way you can do the puts. So I would do the puts here or you can do an out if it's only one character, right? But if it's more than one character, we would do the puts. And as we loop, right, the part of your body is also incrementing X. So we know that register 0 has X. So we take register 0, add 1, and put it back on register 0. So we just finished this statement right here for incrementing X. And then we want to take what's in register 0 and we're going to store it to register 5. So as you can see, when we're using register to register, you're going to do an STR like this. Right? You can also do an ST if you're not using directly register to register. And then we want to do the jump, or you can also use BR here. I often do the BR, but you can also do a jump loop. So it is an unconditional branch. So it's going to come back to here as long as it is true. Okay, any question? So this is a good example to kind of look at on how to implement a while loop, right, in LC-3. And then, so we just did this one. Okay. Now for the for loop, if you compare the while loop with the for loop, it is slightly different, right? And I know we know that in C++ and Java, and it's different as well. So for the for loop, keep in mind that when you learn C++ or C, you know that it has 3 parts: where you start, where you finish, and how you update. That's a for loop. So we would need to be able to iterate through, starting with the first round, which is your index is going to be 0, I is 0. Some people use I, some people use N or count. Okay, so that means that I have, just like what we did before, we're going to work from inside out, inside the parentheses, and we're going to piece each of this part in LC3. Okay, so we're going to treat I as a variable, and as we see a variable, we're going to represent that with the register. So here we are going to use register 0, and we're going to initialize it at 0. Let's make the assumption that I is register 5. So we are going to store register 5 to register 0. So I is equal to 0. And similar to what you see with while, right? You store here, so you're going to reload it. You're going to load it back to register 0. So you're going to load I. And then, so we already did this part at the above, right? Now we're going to subtract 10 to check for I. So you're going to subtract 10, and that's your max value in your, that's your max counter value in the for loop. So subtract 10, and it's going to check register 0 here to see whether it's 0 or positive. So if it's 0 or positive, we're going to send it to done, very similar to the while loop, right? Now, if it is not, if it's negative, then it's gonna execute this part, the loop body. So we're gonna load register 5, which has I, and we're gonna load that back to register 0. Then we're gonna take what's in register 0 for the ... here, just like what we said before, right? We're gonna ASCII convert, and then we're gonna output. So we're gonna keep it on register 0 and do a put. And we need to reinitialize. Now this is the difference, right, between the while and the for, is that we have to count up, or we need to update. We got to do the third part, which is the update. So you're going to add 1 to register 0 as it is the register for your counter. And then you need to store that because R5 is I. And then we can do a BR or jump back to the loop. Okay. So it's going to increment. So that's the update part. So it's going to start at 0. It's going to go up to 10. And each time it's going to count up. And this is how we write a for loop. Any question? Okay. So let's take a look at the number 5. You are to write an LC-3. And I put a snippet because this is, we're not really, we can run it and set values for X to see what Y is as an output. But, we want to really have more of a complete program than just this, okay? So we want to create an LC3 program that represents this statement. If X is equal to 4, Y is 7. And that's pretty easy. You can follow the example on the slide, or you can I'll walk you through. So like any of the LC3 program, we're going to start with the origination address. Originate at hex is 3000. And like I mentioned before, right, we're going to work inside out. So we want to use the tests for the evaluation expression here. So you're going to load X to register 1. You can use register 0 or another register as long as you can track it. So what I want is I want to keep X intact. I normally do that because otherwise I have to save and restore. So if you want to reuse that register, you can save and restore. So in this one, I chose to copy it. So after I load X to register 1, then I copy it to another register, register 3. Because I want to keep register 1 as X for other reasons, right? Because we might need it for other things. If not, you can use the same register without copying. Then now, once I have X copied to register 3, I'm going to go ahead and subtract 4 to evaluate my expression. So R3 add -4. Now, if you're using an assembly language that does not allow you to add negative decimal, you have to do a 2 complement of 4. So you need to bring 4 into a register. So I would add 4 to register 2, for example, and then add register 2 to register, 2 complement register 2, and then add register 2 to register 3. Okay, so you have to do the 2's complement when you don't have the add sign extended value. So here we're going to add -4 to register 3, and that allows us to check to see if it's equal to 4. And I chose to use not true here, okay? But you can also branch for true. You can say branch 0 true. We can send it to the true section, right? Or you can give it another label and then you can do other things. So if it's not true, I'm going to send it to not true section and it's going to halt. But if we subtract 4 and it is equal to 0, notice that I branched negative and positive to not true. Then if it's equal to 4, then it's going to execute the next line here. I'm going to load Y to register 2, copy it to register 4, add 7 because we want to initialize Y as 7, add 7 to register 4. And then after that, because I loaded at the beginning, I want to store it out so I can check my output. So we're going to store from register 3 for X, and then store from register 4 for Y. And then since we're using X and Y label, we should fill it. So that way you can have input and output at the memory location. So you have X fill is hex 3100 and Y is filled at X 3101. So there are several ways to really approach this conditional statement. I chose to branch to the not true where it's going to halt. If it is true, then it's going to execute this part. Load Y and then add 7 and then store out. The reason why I store that out to the label so I can check after the program is ran, right? Because in order to test this program, I have to set the value before I start for X, right? Like say if I set my X value is 5, and then I run the program, when it's store out, I should see the X value and the Y value, okay, to see if my program execute the condition properly. So just that simple statement, you see that given that I did some extra line for the copy, even if you take that away, it's still quite a few more lines. Okay, so when you work on your project, give yourself time, work a little bit at a time each section, and then go back and track it back. So that way you can see if it's doing what's supposed to do. Any question with this exercise? So at this point in the game, in this class, we should know how to do this, okay? If you're behind, you need to look at the other labs and figure out, and then if you have questions, let me know. But we should be able to write a simple program at this point with at least control statement and even loops. Okay, so next, we are gonna do an if-else for 6. And kind of similar to what you've seen in the example, you can also use the example as a reference, but I don't simply just want you to copy and paste the code from the PowerPoint slide because you won't learn anything. It's always good to kind of practice coding when we have time together in the session. So if you have questions, you can ask. And I'm going to go over each of the part right now. So I have the statement, if X is equal to 0, we're going to increment Y and we're going to decrease Z. Else, we're going to decrease Y and increment Z. Yeah. So we have to think about, we do have 3 variables that we're working with, X, Y, and Z. We first need to target what's in the test condition, which is X. That's what we check for. So that's going to be loaded and start with our program. So that's where we're going to begin. So we would originate our program at hex 3000. That's where we're going to load our software. And we are going to load X to register 0. And here you can, sorry, I had that incorrect there. we can clear register 0, which gives you register 0 is X and it is now at 0. Similar to the last program, I'm going to use branch to negative positive. I'm going to go to else. And else, I have to define that. I'm going to decree Y and increment Z. After I branch, right? So basically, if it is not true, it's going to go to else. If it is true, it's going to execute here. It's going to continue. So it's going to check register 0 for 0. Right? In this case, we're checking for negative and positive and send it to else. If it meets the 0, then it's going to load Y to register 1. And similar to the last one, I recopy, but you don't have to do this one, right? So I copy Y to register 3. The reason why I did this, right, is that because Y is used in multiple parts. So I wanted to use to register to be able to handle it, but you don't have to. You can reuse the same register as long as if the value changes, you gotta save and restore. So either way, it will be 1 or 2 lines of extra code. So we're gonna copy register 1, which has Y to register 3. And so what I'm doing here is I'm working with this and this, okay? So right now it's this part for this. So after I copy, I'm going to increment Y. So I'm going to take that and I'm going to plus it. +1. And then I'm going to store it out to the Y label. Then I got to load Z. So I would take Z and load it to register 2. Again, I copy that to register 4 for Z. So Z exists in register 2 and register 4. Then I'm going to decrease Z by subtracting 1. Sorry, I'm missing the hash symbol there. So we're going to decrease Z. Then I store it out to Z label from register 2 as we subtract it. Earlier we used else, so now we got to define else. And else, it tells us to decrease Y and increase Z. So we are going to take Y. We're going to decrease Y. So Y is already in register 3 where we last copied it. So we're going to take register 3, subtract 1, and put it back on register 3 and then store it out to Y. And then we copy register 4 as Z. So Z is in register 4. So we take Z, add 1 for the increment, and then put it on register 4 and then store it out to Z. And this is the reason why I copy, so that way I don't have to go back, store, and then reload, go back, store, and reload. But ultimately, I do have copy instruction in both parts. So register 4 has Z. I increment it, and then I store it out. And then I halt the program, and I simply do the data part, which is fill X, Y, and Z. So I can simulate and check the values. Any question? So I see a chat question. Why are we not storing indirectly for X? Oh, you can. You can store for X. The reason why it's not needed, okay, I'm going to tell you why it's not needed. It's an evaluated expression right here. Okay, because for evaluated expressions, when you set the value, it's at this address already. So I would set X, for example, I set X is 1, and then I run the program. We're only going to be interested in Y and Z as the condition. Evaluated expression doesn't need to be stored. You can to check the value, but X is going to be X. X is what you set it as at the beginning of the program. So if I set it at 1 after I run the program, it's still going to be 1. So you don't absolutely need to have it store out again. It's still the same value. Now, in the case that if you operate something with X later on in the program, then yes, that's a good idea to store it out. So let's say that this is part of the bigger program, and we say that if X is equal to 0, blah, 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 we do it here. And then we would do something with X down the line. We would say, X is going to be equal to Y squared plus 5 or something. Then you should store that out later on. Okay. Good question. Any other question? So I wrote a couple versions of this. Let me see if it's, yeah. So I'm gonna show you, this is like another version of this where it checked for 0, right? If you're interested to make it exactly like this, instead like where it's true here, and then it's gonna go here, and true section would have this and this. I'm gonna show you how that is. Okay, so for this one, same thing, origination address. And I think I wrote this later than the other one. So every time I do it, it's, I look at how I can do it differently. So I load X, Y, and Z up front. And some of you prefer to do it this way. It's a good way for you to kind of have an idea of what register you're using. Then I initialize X as 0. Right, so at this point, I'm already ready for the evaluated expression. So I'm going to take that X and I'm going to check for 0. So it's going to look in register 1 to see, is that 0? Right, if that's true, it's going to go here. It's going to do this. So when that's true, then I need to load Y and then increment, right? And then load Z and then decrement, and then store out Y and Z. If it's not true, it's going to go to the next line. And then we have to, because we load Y to register 2. So we would take Y, we're going to decrease by 1. Take Z, increase by 1. So Y plus plus, Y minus minus, right? Z plus plus, and then store that out. And so that's how you can do it with the true label. Okay. And then typical halt, fill, and then dot N. So you can see two variation. The first one, which is very similar to the prior exercise. This is another way that you can check for 0. And then if that's true, send it to the true section. And then we would increment Y, decrease Z, store, as we load earlier. Then we would, for if it's not true, then this is the L section. Any question? Okay. So that's pretty easy. Okay. So for number 7, we are going to take a look at the program in C and LC3. Right? We want to be able to put that into LC3. Describe how branching instructions are used and implemented in the while loop. So I kind of went over this verbally earlier, but you can also look at your example. I actually wrote this not using the example. So I'm going to walk you through that so you can see. Okay. So if we take this snippet and we implement it in LC3, this is what it's going to look like with the ASCII conversion. Origination address, right? Recall that we have X is, we need to initialize X and then check for X is less than 10. So I load X to register 1. Then I initialize that or clear it for 0. So here, R1 is equal to X is equal to 0. And then on the next line, we are going to subtract 1. So here is where you evaluate to see if X is less than 10 by subtracting. And since we want to see if it's less than, right, we can actually, we don't need the 0 here. We want to check. Oh, I'm sorry. That's right. We need the 0 there. So if it is not less than 10, that means that it's equal to 10 or greater than 10. So it's 0 and positive. We're going to send it to done. Okay. Now, if it is true, we have to ASCII convert it. And then we have to output it, which is the printf right here. So this is a C statement where it does printf. For C++, you would do cout, right? So we need to get it ready to print, and we want to print out the integer value for X. And we know that X is in register 1, so we want to ASCII convert it. So we add 15, 15, 15 plus 3, that's 48. And notice I'm using decimal. Okay, so I ASCII convert it there. And then what I want to do is I want to also store it out to the X location so I can see. I need another line here. I need to copy. missing that. So I know that X is already, the value for X is in register 1. I start out to X. When I simulate it, I can check, but I ASCII convert it so that way I can execute this line to output. So I need to take that and I need to copy it to register 0 because if you don't, you cannot output. So when we do the put, it's going to pull it from register 0 only. So we need to bring it to register 0. X to R0 to output. And I want to load effective address to register 0. And then that's going to give me the show. Actually, let me think about this real quick. This should go before this. So it is a sequential process, right? And then this should go before this. Sorry, you guys. Do you know what I'm doing is when I load effective address for the show, I wanted to say X is, right? So I'm going to load effective address to register 0 from the show, which is the string. So it's going to say X is, and then I'm going to do the puts for the display. Then I should clear register 0. 0. There are 0 for next display for this for X display. Then I'm going to copy to the X value to register 0. Okay. Then after that, I'm going to go ahead and do another puts. X. So it's going to say X is first step, right? Then it's going to clear that register for the next output. Then I copy X over to register 0, and then I display the value for X. And if you want, you can load it, but sorry, let's get rid of this. Oh, wait. Okay. Then we are going to load X. Store out to X. I don't think we need to do this because your register 1 already has that. So register 1 already has the X. So what I can do is I can do add R1, and increment it with 1. And if you want, you can store that out again for X. X. Okay, That's correct now. So I store X out here because if I take what's in register 0, that's already been output. So I load it back to X because we got to do this part. X is X plus 1. So what I need to do is I need to load X back to register 1 and then I add 1 to it and put it back on register 1 and then store that out to X. And then for my done that I had earlier, that's just going to simply be held if it is not, the condition's not met. And then for my show, I would do a dot string X is, and then I would fill this. And if you want, you can fill others, but you know, I think that's all we need actually for this program. Any question? So let me comment this so you can see. Okay, so that kind of show you how we can take this and make it more complete. You can do it like the example on the PowerPoint, but keep in mind that there are 5 is already loaded with X earlier, so you don't see the complete program if you're looking at the example. So I want to give you a little bit more of a complete example from top to bottom with loading X, initializing it, checking the test condition, branching it to the appropriate area, and then ASCII convert it if it is true, store it, load it with the string, right? You don't have to do the string display with an LEA, but I wanted to make it more user friendly. And then clear it, copy it for output, take the X, and then we already ASCII converted, so it's gonna be outputting there, and then incrementing the X for the next part of the expression, and then, you know, fill the strings, fill the address. Let me tap this so it's a little cleaner, and then do a .n. Okay, so that's how you would do it for that block, that code block. Any question? Okay, we're good. And this is the example from the text. So to add to that answer, right, you see this in purple. Branch is used to check for false condition after R0 is added with -10. If +0, exit the loop and go to label done. And so when you read this, you should look at how this branch is used. The question asks you to look at your code and be able to apply how the decision, right, for the branch is made. So what it does is gonna look at the register 0, the destination register from the previous instruction, which is register 0 here. And it's gonna check to see, right? So branch is used to check for the false condition. We're gonna check after we subtract 10, if it's 0 or positive, which is the false condition. Then if it's 0 or positive, it's going to exit the loop and go to the label done. If it is true, then wait, we should say true condition is continue on the next line of the code after branch. So if it is true, then it's going to go to the LDR here, which is the next line of code after your branching. Okay. It's going to load X and then ASCII, we need to ASCII treat it. Then we output it and then we then increase X and then store it out. And then we can jump back to the loop. That's what I should do up here. You can use jump loop there too. Okay. So if you add the label here, it's gonna make it like a loop. So it's gonna use that label and we're gonna do an unconditional back to the loop at the top, or we can jump back to the loop after it does the increment of 1. Any question? No question? Okay, so let's talk about the next one, which is 8. And we already took a look at this. We talked about how a for loop have 3 parts. Okay. You have the example in the slideshow that you can use. And I mostly use that here. Let me see if I wrote another version. No, I didn't. Okay. So let's talk about number 8. Break it down in case you missed it earlier. Okay, so we are going to take a look at the LC-3. And I modified a little bit so you can see. And what I want to do is I wanted to take this and put it into the LC-3 program. For I is equal to 0, I is less than or equal to 8. We're going to increment I. This is part of the loop. We are going to output the index value. So to make it more of a complete program compared to what you've seen in the example, I modify it a little bit. So I took what's there. You can copy and paste it if you like. And then I'm going to show you what I added. The reason why I add some of the elements is because as a programmer, I also want to verify if I'm getting the right output. And then I kind of wanted to also check back and in case if I need to debug it. So initialize register 0 with 0. So here we are going to have, we clear R0 basically. And then on the next line, I load I to R5. So in the example, it just make the assumption that we have to make the assumption that I is already been loaded to R5 because you do see some store and load later on using STR and LDR. It's fine if you don't load it and you can still store it, but you have to know that register 5 is treated as I. So what I did was I tie it to a label, which is an address location, so I can verify. Okay. Then after that, I'm going to go ahead and store it back. So I would take I. Another way that you can do this is you can copy, right? We can copy or to R0. So a way that we can copy is we can take register 5 and then add it with 0 and put it on 0. It's the same thing. This is like very... Now in the back for the processor, it is a little different on how it uses memory location, but ultimately you would achieve the same thing if you're doing a copy here. Okay. So what we're going to do is we are going to copy register 5 to register 0, basically. So it's going to write the value for I to register 0. Then we enter the loop. Okay. Then we're going to load I again from register 5 to, and in this case, we load register to register. So you're using LDR, register to register. And then we want to go up to 8. And this one we stop at 8. So we are going to subtract 8 from register 0 because that's where our I is. And if it is positive, we're going to halt. So we're going to go to done. Now, in the case, if you want to do negative and 0, right? You can have it for this section. So I chose to use positive, go to done, because if it's greater than, then it's going to stop. Exit the loop. For the loop body, we're going to again copy I to register 0 or load it. So we're going to read the value from register 5 and put it on register 0. We have to ASCII convert it. So in the example, this is the ... So we ASCII treat it here. And then I wanted to put it back on the label. Actually, should be an STI. Store it back to the label so I can also check. And then I wanted to keep it from register 0 so I can output. So I would do a put there. Then for the next part, remember that we have to do the update. So we are going to increase, so take I and +1 to it. And then we would do a register store. So we would take register 5 and then store it back to register 0. So it updates the count. And then we would do a jump. Again, you can do a BR loop here. Okay, questions? So the things I did different on this one, right? We loaded I to a location. We ASCII convert. We store it out to that location so we can verify as we simulate. If you do a step through, that's easier for you to check. Or step over actually, and then output. Everything else, pretty close to what you see with the example. Okay, so that's how you write a for loop with LC3. So after this session, right, no excuse in not knowing how to write loops or control or conditional statement. Now, if you want to, make it complete, add origination address, do the fill, right, with the address for I, and then have the done. So I'll do that for you also. That's it. And then at the top, just need to add. It's always a challenge to work in Word. Okay, so origination we added, and then we added some of the things like the done, the whole section, and then the fill for I. Okay. Okay, just a couple more and then we'll finish. For number 9, it says, what are the primary differences between do while and for loops? For do while, your condition is test, or the test is evaluated after executing the body. Compared to the while is before execution. The do while is after executing the loop body. So it's going to execute the body, then it's going to test, where if you only have the while, it's going to test before. For the for loop, the test is also evaluated before the execution. Okay, so that's the main difference. Okay. Lastly, number 10. Let me move to the next page. What does the following loop do? Right, see if you can write an LC3 with this. So you already have the for loop from the last one, modify a few things. So the for loop, we have 3 parts. I begins at 0. It's going to go up to 20. It's going to update. So we're going to increase I each loop. we have a nested if statement. If I mod 2 is 0, continue. And then output I. Okay. So this program is going to loop how many times? 20 times, right? And for each loop, it's going to check to see if I mod 2 is 0. If it is, then it's going to go to the next part of the program, continue, and output I. If it is not, right, then it's going to exit. It's not going to execute this. Okay. So for I, so it's going to exit the loop. So as long as it's true, if I mod 2 is 0, it's going to print I, and it's going to keep looping. If it's not, then exit loop. And there you go. So it should take you like a few minutes to write this in LC3 actually. Very easy. Origination address, just like what we did before. Bring I in, initialize it at 0, right? Subtract it by 20, check for the branch. If it is 0, right? If it's positive, then we can have it halt. And then for the next part, you can just have it increment of I and then implement this. So this is going to divide by 2. So implement division, check to see if it's 0. If it is 0, right, go to the next line. And then we're going to ASCII convert I. Then we do the puts and so on. So I want to say about 20 something lines. Okay, any question? All right, I'm going to stop recording.